What's the fourth problem is? Okay, our fourth problem actually asks us to find the secant of pi over 2. So let's just write a problem number 4 here, and it asks us to find the secant of pi half. Alright, so we know that the secant function is actually equals to 1 over the cos of an angle. So the secant of an angle is equals to 1 over the cos of an angle, and secant of pi over 2 is equals to 1 over the cos of pi over 2. Next up, we use our unit circle to check what the value of cosine of pi over 2 is. Again, we have a circle over here, x, y, and at pi over 2, actually, let's just draw a circle a little bit nicer, because the center of the circle is supposedly on the origin, and it just doesn't seem like it. Cool. I'm not sure if this circle is better, but I think there is a little of improvement. Now, let's look at the angle pi over 2. So the angle pi over 2 radians is 90 degrees, which is, which is right here on the y-axis. We know that the value at pi, the value over here is actually 0, 1. And we know that on the unit circle, the cosine values are the x values and the sine values are the y values. So we know over here, the cosine of pi over 2 is actually equals to 0. So secant of pi over 2 is actually 1 equals 0, which doesn't have a result because 1 over 0 is not defined, which is basically just a fancy way saying that 1 over 0 it's just undefined. It's undefined. So like it's not like you can't get an actual numerical value out of it. So you're just saying that it is undefined. This is like a mathematical term you use in this case. So the answer of secant of pi over 2 is just undefined, and that is your exact value of secant of pi over 2. That is undefined because it doesn't. You don't have this exact value. Alright, so this is our solution, and let me show you something else quickly. So let's draw, or I guess let's use our graphic calculator. Let's draw the secant of pi over 2, or I guess let's draw the secant of x. And I guess I can't change the color. Nope, can't. Okay, so this is our secant function over here. This is what it looks like. It basically looks like a parabola. It looks like a lot of positive and negative parabolas spread out on the plane. This is what the secant of x, the function of the secant of x looks like. Now let's find where x equals to pi over 2 is. Pi over 2. Alright, so the line in red is x equals to pi over 2. We know that over here on the secant function, when x equals to pi over 2, the value of y actually doesn't exist. Because notice how right over here, the secant function, which is the black line, is approaching the red line, which is pi over 2, infinitely, but it never really reaches the red line. So like you can see from here that it just try to approach or try to reach to pi over 2 and never reaches it. That's why the value of secant of pi over 2, which is the y value of the function of secant of x at pi over 2, it doesn't have an actual value. And because of the vertical line here, it's called an asymptote. Because of the existence of vertical line here, we call this undefined, meaning it's trying to reach it but never actually gets there. Similarly, from the other side of the red line of pi over 2, again the secant function tries to approach the line of pi over 2, or try to approach the value of pi over 2, but it never gets there. So yeah, again the value of secant of pi over 2, it is undefined in this case, and that's how we write our answer. So yeah, this is what I'm going to cover for this question, and let's look at the sample solution now. Yes, they also mentioned that it is undefined, and they also drew the secant function, They didn't put a line here for the value of pi over 2 for it to be more clear, but I guess it's alright. So yeah, let's just say, great job. The solution is correct. The solution is correct. Perfect. Now let's move on to our next problem.